Okay, we're going to try another one this time. We have this function, x to the 1/3. There's the graph. And we're going to try our initial guess as 0.1. We can see the answer is 0. But let's see what happens when we try Newton's method on this sort of random function. Okay, so I have my function, I have my derivative also. And now let's go ahead back to the home screen and put in our initial estimate as a 0.1. Then I want to call up my other function, which I know is there. So there it is. And hit enter. There's my first estimate. You might notice right away that, hey, wait a minute, it got farther away from the estimate, not closer. Farther away from the answer. I could see the answer is 0. I hit it again. Uh-oh, even farther. Farther. This thing is diverging away from the solution to the equation. We know our solution is a 0. And yet this is failing on us in the worst way. It's going off course completely. So this can happen when you have an infinite derivative, when you pass through an infinite derivative at your 0. And that's what we have here. So the method can fail when the derivative at the 0 is infinite. So there is a condition, though, sufficient condition for convergence. Sufficient, not necessary, but sufficient. And that is this thing down here. You'd have to do the computation, check this, and to see if this holds in the window that you're working. Okay, so there's a little bit of work involved there, but it could be done. Okay, and I just wanted to bring that up. We're not going to actually do anything with this at this point. This is enough. I mean, we go so far in this intro course here. We're not going to get deep into the method. Okay, so just be aware of that problem. If your 0 happens to be at the place of an infinite derivative, then the method will fail. But there are conditions. There's a condition here that's sufficient that will guarantee that the sequence converges. But we're not going to actually do any problems with that. All right, let's move to the next method.